In this video, we're going to solve problems involving similar shapes where we've got two triangles that sort of meet in the middle like that. So what does similar mean? Similar shapes we saw in the previous video just means they are the same shape but different sizes. And what's a really important thing about being the same shape is that all the sides are scaled by the same scale factor. So if you were to double like the bottom length of a triangle, then it would double the height of the triangle. All the sides lengths are scaled in the same way. But how do these two triangles interact? How can we compare them? Well, let's look at the angles. If we had this angle here, where else do we have this angle in the diagram? Now, can you see that we have this kind of Z shape like this? So we've got a Z shape like that, where the two ends of the Z are parallel lines. Now, these are alternate angles. So the angle between the first two lines, so here and here, which is that angle, has got to be the same as the angle between the second and the third line, so this angle here. So if I just rub out those lines, we can see that we also have that same angle at the top right here. It's the same as if we compare this angle to that one, because again, we've got a Z like this, where the two ends of the Z are parallel lines. And finally, these two angles are going to be the same because they're vertically opposite. Now, it might help to actually draw these two triangles separately. So if I have the two triangles, and I'm going to draw the angles in them. So we've got a black angle in each, and we've got an orange angle in each, and we've got a blue angle in each. Now let's compare the lengths. So in this first triangle, the 10.5 is between the orange and the black. So between the orange and the black, that's 10.5. And we can see the y's between the orange and the blue, which is y is here. Now in the smaller triangle, the 7 centimeters between the blue and the orange. So blue and orange, that's 7. And the 3 is between the black and the orange, which is here. And if we look at these triangles, I'll put them in the same orientation. So the blue and the black at the bottom of each one. So for example, this length here is comparable on each triangle. It's the top right side of each of the two triangles. So whatever this scales by has to be the same as what this purple length scales by. So the 10.5 to the 3, what is the scale factor? Well, if you divide the numbers, so let's just say I do the bigger number, 10.5 divided by 3, it's 3.5 times smaller. So if this length on the left of the triangle is becoming 3.5 times smaller, that means the yellow length must be also becoming 3.5 times smaller because they're the same shape. They are similar shapes. So then to go backwards, what number divided by 3.5 is 7? We just do 7 times by 3.5, and that gives you 24.5. So therefore, y must be 24.5. And you can sort of see in these shapes that like the 10.5 and the 3 are comparable. So you find the scale factor here between the 10.5 and the 3. We can see that's 3.5 times smaller. And then these two lengths here are comparable here and here. So the 7, we make it 3.5 times bigger. We do the 7 times 3.5 to get that length there.